So we've got our primary equation set up. Everything's in terms of a, so we want to go ahead and take the derivative, set it equal to 0, and solve for a. But before we do that, I'm going to distribute this a across, so this becomes negative 4/5 a squared plus 4a, and we'll just label that as a for area. Whoops. My workspace has gotten kind of cluttered over there. Okay. Um, Scrolling on down. So we want to take the derivative of this. We'll bring the 2 out front, and 2 times 4 is going to be 8. So we have negative 8/5 a plus, and the derivative of 4a is just 4. And that is our derivative. We set it equal now to 0, and we solve for a. I left off my a right here, and there was something else I noticed. So math is all about pay attention to detail, isn't it? Alright, so negative 8, or actually positive 8/5 a is equal to 4. And we multiply both sides by 5/8. So a is equal to 4 times 5/8. And then we can simplify this down even more. A is equal to, so let's see, 4 goes into 8 2 times, and we are left with 5/2. We're left with 5/2, so that goes into, let's see, 2 point something times. So a is equal to 5/2. Right. And so to find what this other point is, you're going to take the 5/2 and plug it back in, right, to the equation for our line up here. And I'll just do that right here. So we're plugging in 5/2, right? So this to find the other part of this ordered pair is equal to negative 4/5 times 5/2. Hey, that's nice. 5's cancel out. 2 goes into 4 2 times. We have negative 2 plus 4, and that just gives us a 2 there. Alright, a 2. So our actual ordered pair up here, we'll have to write it down here. So the point on that line, 5/2 and 2, that's going to be the actual point on the line. And if we wanted to find the actual area of the area of the box, you would take the 5/2 and the 2 and plug it into either one of these right here. That gives us the actual area. But I think what I'm going to do here real quick is I'm just going to graph this. So let's graph this and see if we come up with these same numbers. Hopefully we do. Alright, so we graphed the equation for our area, which was negative 4/5 x, or what was it, a squared plus 4a. Anyway, as you can see up here, when we graph this now, this graph, the x represents the a, of course, and then the y-axis represents the area. And as you can see, we have a maximum up here at the top, and of course at 2.5, and then the 5 is represents the area in this ordered pair here. So you have a maximum area of 5 and 2.5, and then we just take the 2.5, of course, and plug it in to find out what the second part of that ordered pair was. So it's always nice to graph this stuff. You can check your work or skip the calculus and just graph